Are we here? Can you hear me? How's it going? Did you have a good weekend? How's it going? Have we made it through another week? We're now on week 3 of this virtual learning. Hey, Amanda, do you see my cool new pen? Isn't that cool? Isn't that clever? Look, this is great. Look, we got magnets too. Cool magnets. Cool magnets. We got stickers. We got cool merch. We got swag. Yeah. Our own little branding here. Got our own stuff. It's cool. I know it is cool. It really is. Coming up in the world. Now we need like shirts and bumper stickers. Market ourselves. I'm not too fuzzy, am I? A little bit fuzzy? Oh well. I can't figure out how to work the camera so that it's not fuzzy. Maybe it's better that way anyway. You like Jake's haiku today? Let's see. Great as a teacher, Pimpson should not be trusted inside the kitchen. Yeah, that's 575. Follows the pattern of a haiku. This originated because earlier today I was trying to cook, and we were on Discord, and I didn't realize that I had my mic down, and so Jake was teaching me to cook, and eventually kicked me out and said, hey, you're not allowed to cook anymore. And the whole time the people on Discord could hear all that, and so at the end they were laughing hysterically, and so then he wrote the haiku. Turns out I can't cook. Amanda can attest to that. I will burn anything. Like I can't cook. Nobody will eat my food. So, hey guys, I'm doing great. I'm glad y'all are here too. It is kind of rude, Thomas, but I kind of believe it. That maybe I don't belong in the kitchen. I'm not very good in there. I can do the math, but I'm gonna burn it. I'm gonna walk away from it and it's gonna burn because I can't stay focused on that one thing, and cooking requires attention. So, hey Austin, Thomas, Marissa, Rachel, and September, all here. Woot woot, way to be, way to be. So I have to be careful when I'm on this. I love the Discord. The Discord is the way, man. It's so much better than trying to text with y'all. Just being able to talk to you on Discord is so much easier. So that's right. That's where I belong. It's right here in front of my whiteboard, teaching. That's it. None of that cooking business. Somebody should just bring me food. And we have an early bird. It's kind of a challenging early bird. Oh, I didn't tell you what to do on it. I want you to solve for y. See if you can do this, and then we'll talk about it. Struggle through for a minute. So I want you to solve for y. See if you can do that while people show up. I do too, September. There's a lag, by the time I get y'all to answer. And especially tonight for this early bird, this is like the whole lesson. So usually I walk around and help you as you're doing it, but y'all aren't going to get the bit. I can't see what y'all are working on. I can't say, wait, what about this step? So I too miss it. But it has been nice sitting with you to do the homework on Discord. That works as well. We're doing at least that is better. The rest of y'all should join us too. Get on. Get your homework done. Get it turned in so you're done. Some of y'all haven't done anything yet. Not calling out any names, Austin. Get to work. Turn something in. Come on. Hey, Cheyenne. Woot woot. Way to be here. Y'all get something done. Turn it in. Like for reals. Gotta earn those points. Make the points, make the points. Get something done. All right, tell me what you did first. I don't know yet, Thomas. I'm gonna predict that it will be like this. That's my prediction, but right now they're planning for face-to-face classes. There has been some talk of delaying class a little bit, like not starting it right at the end of May, but maybe starting it 2 weeks into June. It kind of depends on this whole virus thing and when our peak is. Right now, I'll post that in y'all's content too. I posted in my stats discussion about the peak and when it's supposed to hit Texas, and right now it's supposed to, because we've been socially distancing, it's going to be later in May, and it's going to be a lower peak. If we stop social distancing at some point, then that peak will come earlier. And it'll be worse. It all depends on what we do and when that thing's going to come. So, but yes, the rest of y'all should take the stats class too. You want you need, in this class, you need 450 for an A, and I sent y'all each individual emails telling you how many points you have and how many more points you need. So hopefully you got that email. You can go look and see. The little bold part is the part that you need to know for what you want to make. So, yeah, let's just get it over with, get this done, and then take it this summer. I agree. Earn your points quick, Austin. Get those points, and then you can be done. Get your 350 points and say peace out. Or your 400 points and say peace out. Or your 450 points and say peace out. So, come on. Sit with me on Discord after this. Let's get it done and get it turned in. All right. Tell me what you did first. What are we doing first here to solve for y? If we're going to solve for y there, what are we going to do first? By the way, we've been having some trolls drop in on all my classes because this is just public and anybody can be on. If somebody does hop in, y'all just ignore them because that could happen. Just ignore them. If they want to sit around and learn some math, they can stick around. They might say some inappropriate things, but if we ignore them, they seem to go away. That's what I found. Oh, I'm going to do that in a little bit, Cheyenne. We're not looking for a inverse yet, Cheyenne. Right now, I just want to solve for the y. So tell me, what do I do? Oh yeah, don't be wrecking homes. Yeah, none of this, because you're right, there's wedding rings involved, so none of that wrecking home things. So how can we solve for y? Remember, our whole goal is to get y by itself. So what do I need to do to get y by itself? Get out of the way of the board so you can see it, that's one thing. Maybe first, I like it. Multiply both sides by that denominator, and that'll get rid of our denominator. Let me see if I got a marker that works a little better. So I'm going to multiply both sides by this denominator. Okay, so getting rid of that denominator, ding, ding. And on this side, I'm going to distribute it. So I have 6xy minus x equals, now I'm at least done with the fraction. Okay, now I'm solving for y. My whole goal is to get the y's by themselves. So what do I need to do now to get the y's by yourself? What do you think we need to do now to get the y's by themselves? What should I do in this case? I just distributed that. So now what? Here's the hardest, here's one of the hardest. This is not the hardest, but this is the hard step. If I divide by 5, I end up having to divide everything by 5. And notice, I have a y over here and a y over there. So you're right, normally, even then, before I divide by it, before I split that kid off his parent, I want to send the kid away, remember? So before I do that division, I first want to send him off to play blocks. So let's do that. Let's subtract 4 from both sides. And when I subtract 4 from both sides, well, he doesn't have anybody that's like him. So he just is on that side over there. That becomes 0, so I'm just left with the 5y. Now, it is true that typically when we get to this point, we go, well, I'm just going to divide by 5. But notice I got y's here, and I got y's over there. So dividing by 5 is not going to get y by itself. So what do I need to do first to help get y by itself? What am I going to do next to get my y's by itself? So this one's tricky. What do I do next to get that y by itself? And I'm telling you, it's not divide by 5. So what do you think we could do to help get our y's by itself? Tricky, tricky, tricky. Anybody got an idea? Now, if I divide by 5, I'll just show you. If I divide by 5, that goes away, and that y is by himself, but look, there's still a y there. So I did not get all my y's by themselves, because he's not there with the other y's. So think about this. If I had something like 2x plus 3 and an x over there, what would I have to do? I see it. What would I have to do there? I'd have to first get my x's on the same side. So you're right, Rachel, I've got to get these y's together. These y's need to join those y's. And the way I'm going to join those y's is to subtract that 6xy from both sides. That's tricky. It is tricky. Those were all good thoughts, though. So now I have negative x minus 4, because that becomes 0. And then I've got 5y minus 6xy. Now I'm still trying to get y by himself. And right now, y is mixed up with a bunch of characters. I need to do something to help separate out that y from the rest of the guys. What could I do to help pull that y out? What could I do to get him away from those people? Can you think of something we could do to help pull that out, to get him out of there? What could I do? They are, I agree. There's some shady characters. I got to get him out of that situation because right now he's in a bad situation. How can I pull him out? What can I do to help get him out of that situation? Think about my favorite thing to do. So dividing by y is a good idea. Maybe if I divide it by y, it would pull a y there and it would pull a y there, but then my y would be on this side in the denominator. So that's a good idea. You know, think about it if I do this, but now my y is down here in the denominator, and I don't really want that. Oh yeah, Marissa, my favorite thing. Let's F this thing. Let's factor him out. I'm going to pull him out by factoring out a y. So y can come out and y can come out, and it leaves me that 5 minus 6x. Now y is almost by himself. So see how I pulled out that y? Now y is almost by himself. What can I do now to get get y by himself. Last step here. And I'm going to get y by itself. This is a tricky, tricky thing. Now what? Now what? What? He's almost by himself. He's multiplying opposite of, or inverse multiplication. What could I do? How about we divide by that crazy thing? Because look, he doesn't have a wedding ring, so we can divide him off. That's okay. He becomes 1, and I now finally have y by himself. So now, y equals negative x plus 4, oh no, minus 4, sorry. Minus 4 over 5 minus 6x. Yay, y'all got this. So, this is the hardest, this is exactly what you're going to do on your homework tonight. You're going to be finding inverse functions. And in there, you're going to be solving for y. And this is the hardest one you're going to have to do. This is the hardest thing tonight to do. So you've just done the hardest one. So notice how we did it when we had y's on top and bottom. First, we got rid of its the denominator by multiplying both sides by it. Then we needed anything without a y on one side. None of these have y's. And everything with a y on the other side. Then we factored that y out and divided. It's a lot of steps. So, but this is the, once you can do this one, then we're going to be in good shape. Yeah, I know. What I think is the hardest one, it's going to be all right. This is it. This is the hardest one you're going to do tonight. This is the hardest one. This is it. Especially after show you everything else you need to know for tonight. And basically this is what we're doing. We're going to be solving for y. So now let me back up and just show you what it is that we're doing. We're going to talk today about inverse functions. Inverse functions. And if I ask you what's the inverse of multiplication, you're going to tell me the inverse of multiplication is division. When I ask you what's the inverse of addition, you know that the inverse of that is subtraction. These operations are inverses of one another because they undo what one does. And that's all an inverse function is it undoes what one function does. So remember those machines I drew last time? I'm going to draw them again. So let me draw the machines, my functions. I keep drawing these crazy functions, but I always think of functions as like a Coke machine. So here's a function, and here's another function. And we'll call this first function, how about we look at x cubed? I bet you can even tell me what the inverse of x cubed is. I bet you can tell me, what is the inverse of x cubed? If I asked you, what's the inverse? What undoes an x cubed? I bet you can even tell me what that is. What is the inverse of x cubed? We will be graphing September, just stuff that we already know how to graph. So it's just practicing what you already know. We keep graphing and graphing and graphing. So what is the inverse of x cubed? Oh yeah, the cubed root, exactly, the cubed root of x. Exactly, to root it. Cubed root of x is my inverse of that. It just undoes it. Now I'm going to prove it to you because we're going to inverse it. I'm going to show you that it undoes it. So I'm going to put it in the first machine. First machine's going to cube it. So pick a number like 3. If I put 3 in, all that says is do 3 times 3 times 3, which 3 times 3 is 9 times 3 is 27. So this first function, I put in my money, I hit my button, and out pops a Dr. Pepper. I'm going to take my Dr. Pepper now and put it in this other machine. And in this other machine, it takes it and finds the cubed root of it. But what's the cubed root of 27? It's 3. So notice I got my money back out. Put my Dr. Pepper in, out came my money. It undid what I had before. So we just undid each other. So that's all a inverse function is it undoes what the other function did. When I put it in, get it out, put it in, get it out. Now think about, when I'm putting it in, this is my x value. Y'all agree with that? I put it in, I get my x value, and out comes my y value. Now over here, that y value became my x value in this function. So here my x value and my y value, they swap places. My y becomes my x. And do you remember when we graphed these two functions? So let's talk about graphing them again. Y'all know these parents. You know that you memorize these parents. You got so good at them you could do them in less than 5 minutes. I know you did that even though I didn't get to test you over it in class. You memorized them. So you know them in less than 5 minutes. So your cubic function was -2, -8, -1, -1, 0, 0, 1, 1, and 2, 8. And you remember when you were memorizing them, that it was easy to remember the cubed root one because we just took our x's and our y's and we flopped places. Our x's and our y's, so in here when I put in -8, out came -2. When I put in -1, out came -1. 0, 0, 1, 1, and 8, 2. Notice we said these are inverses of one another, and their x's and their y's just swapped places. So that's a characteristic of inverse functions, is that they undo one another, and their x's and y's swap places. So here are some characteristics. Characteristics of inverse functions. 1, the x and y swap places. All right, now I'm going to graph these two and I'm going to show you something else, another characteristic. So we know these two functions. I'm going to graph them on the same coordinate plane. So in -2, 1, 2, down 8. 1, 2, 3, 4, 5, 6, 7, 8. -1, -1, 0, 0, 1, 1, and 2, 2, 3, 4, 5, 6, 7, 8. 8, and remember it looks like 3rd Street right there by the taqueria. I miss the taqueria. I miss my going out to eat. Once upon a time when we did that. Now I'm like eating healthy and crap. And cooking, but I'm not allowed in the kitchen anymore. I got banned today. No more, no more. I tried to cook. Apparently it's a mistake. So now I'm going to graph my cubed root of x. So I'm going to go out to -8, 2, 3, 4, 5, 6, 7, 8, down to -2. -1, -1, 0, 0, 1, 1, 2, 3, 4, 5, 6, 7, 8. And there's my cubed root function. Remember, it's that third street sideways. Now, another taqueria, I say it funny. Trace. It's my attempt. I'm trying. Would you rather I be like taqueria? No, I can't even do it. Taqueria? Is that better? Taqueria? Okay, notice with this, another big deal with inverse functions is when we graph them. By the way, welcome, Robin. Glad you're here. When we graph them, notice that they are symmetric about this line. See how if I were to fold it on this line, on that y equals x, that parent function y equals x line, that this dot and that dot would match, and well, those already match. Those already matched, and this dot and that dot would match if I folded on that line. So that's another characteristic of my inverse function, is they're always going to be symmetric. The graphs are going to be symmetric about that y equals x. So another characteristic is the graphs are symmetric about y equals x, about that linear function. I agree. Don't forget to like and sub here, and subscribe to my channel. Look, did you see my new merch? Wait, where is it? See the new merch? Look, we got pens. Aren't we cool? We got magnets. Can you see the magnets? Aren't we cool? We got merchandise. Simpson math. Marketing. We're marketing. Doing this right. Now you'll just have to tell your friends about us. Tell them to watch Tuesdays and Thursdays at 6 o'clock. I give them bonus points too. All right, so there's that graph. And tonight as we graph things, we'll see that the inverse functions are always going to be symmetric about that y equals x. Do you have a pen collection, September? All you had to do is make a perfect score on the test and I would have given you a pen, but no more tests. Now how am I supposed to give out pens? I guess if you make a perfect score in the class, you get your 500 points and I'll mail you a pen. That's all it takes, perfect 500 points. Okay, so these are the characteristics of an inverse function. So now let's just practice a few things. First, let me give you a graph and let's see if we can come up with its inverse. I'm just going to graph some random function. So here we go, some random function. How about it? -2, 0. And at -1, 2, there's a point. And at 3, 4. 1, 2, 3, 4. Here's some function. All I want you to do is graph its inverse. Now, I'm going to give you some notation for that inverse, okay? So if this thing is called f of x, if I call this function, here I'll use pink. If I call this function f of x, then we call its inverse f with this little -1. It's not an exponent. I know it kind of looks like f to the -1, but it's not. This is just notation. That means the inverse of that. That's all that means. And you're exactly right, Austin. All I'm going to do is take my x's and my y's and swap them. So I'm going to write down the points so that I see what they are. So this one's at 0, 2, and that one's at 2, -1, and this one's at 3, 4. So tell me, what are the points of the new function? It does look that way, September. It does look like it's irrational because when we have an x to the -1, it does usually make a rational, but in this notation, it just means it's inverse. It's not actually an exponent. So we're using that same symbol for something different. And part of it is it's not on the x, it's on this function. So I'm saying this function, this is the inverse of that function. So that's what that is. Good, I like it. So oh, you're close, just swap it, and you don't have to swap the signs, just swap the two numbers. So it's just at, oh, you're right, it is a -2. Never mind. You're right, that's a -2, that's a -2. I just wrote it down right. Wrong. So I like yours again. -2, 0. Good. So -2, 0. You're exactly right. And -1, 2. -1, 2. Way to be. Way to catch my thing there. And then the last one is at 4, 3. Good. So its inverse just looks like that. We flopped those numbers. So all we did was take each one of these and flop them. So that 3, 4 became 4, 3. I should have done these in the opposite colors. This one became -1, 2. And that one became -2, 0. And notice that if I draw that line through y equals x, that it is symmetric about that. See this point and that point, this point and that point, this point and that point. See how if I fold it on that line, they match each other? So that it really is symmetric about that line. So tonight in your homework, you have some where you're finding the inverse of the function. Don't freak out over it. You're just going to flop their numbers around. Just switch their x's and y's and graph that. Okay, so by the way, let me ask you this. What is the domain of f of x? So if we look at the domain, remember domain, and I'm looking at my pink one. So domain of f of x. What is my domain of f of x? That would be great, September, just to show that they are really symmetric so that you can kind of check yourself too. And you can just show me the points and then rewrite them swapped as your work, and that works too. Be sure and label the graphs though so I know which is which. Like I didn't label it. Label them so I know which one's your inverse and which one's the actual thing. Yeah, good. It's going to go from my domain, starts here at the pink. So my domain for this pink one starts here at 0, and it is included, so I'm going to use a bracket, and goes from there to, let's see, it actually stops at 3. I know that I do them in the wrong color, so it makes it confusing. So it just goes from 0 to 3. So my domain there is from 0 to 3. Then, what is the domain, or what is the range? Yeah, let's do this. What's the range? I think y'all have already done that. What's the range of f of x? And I think y'all already looked at that. Good. So for the range, I'm going to start down here. And it is included, so I put the bracket. And it goes up to 4. It stops at 4. So it started at -2, and it went up to 4. But September, you're like, wait a minute, I just gave you the range of the the domain of the black one. Notice that domain of the black one, what September said, is exactly the same as the domain of as the range of the f function. So this black one's domain goes from -2 to 4. And the range of this one starts at 0 and goes to 3. So just like their x's and y's swap, their domain and their range swaps. So for this one, for f of x, this is the range, 0 to 3. And for the inverse of x, that's how we really read it, the inverse of f of x, the inverse of f of x, this is the domain. From -2 to 4 is the domain of this black one. There you go. So that's another characteristic, is that the domain and the range swap. Which makes sense. If their x's and y's swap, then it makes sense for the domain and range to swap. Good. More people watching, better. Good, 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 good. Way to be, way to be. Y'all got to stay on and answer questions, though. Keep listening, keep learning. I like it. Okay, so now we've got, all we did was take our x's and y's and swap them to get that inverse function. So that's what an inverse function does for us. Okay, so now I'm going to get really crazy, and I'm going to give you some mathematical definition for this inverse function. So the layman term is, it just undoes what the other one did. Our x's and our y's just swap places. So nice and simple, that's it. Now I'm going to give you some big fancy words for it. Okay, remember the compositions we did last week? That f of g and that g of f? We're going to use that in our definition for inverses. Looks like this. By definition of inverses, two functions are inverses. We'll call them, two functions, we'll call them f of x, and we're going to use that inverse function notation. So our two functions, this one and that one, are inverses. Those two functions are inverses if and only if. So in math, this if and only if, it's a really strong condition. So I know it looks like I just misspelled something, right? If. But in math, it means if and only if, and it's like a really strong thing. These things have to both be true. If and only if, when I do the composition of the function, remember like we did last week where we did f of g? When I compose the functions, I get out an x. And, so that has to be true, and when I do the composition the other way, it also is equal to x. So this has to be true, and that has to be true. Remember how last week when we did f of g and then we g of f, most of the time they were not the same. But in this case, they both have to equal x. If that is true, then I'm going to put one other little mathematical thing in here to make it like correct, and I'll explain it. It looks really fancy. Down here I'm going to say for all, that upside down A is for all, or for every x in the domain of this guy. And that has to be true here. For every x in the domain of that guy. So it's just going to, when I put this function in there, it's going to undo it. And I'm going to show you how it undoes it. I know it's big fancy talk, but it just undoes it. And in fact, you had one on your homework where you got this answer, where you ended up with just x at the end. Do you remember doing that on your homework where you had one or maybe even two when you did the compositions that ended up just being x at the end? It turned out they were inverses of one another. So let me show you an example of that. Okay, here's what I'm going to do. You have a couple of in the homework like this, where you use the definition to show the two functions are inverses of one another. Okay, when I ask you to do that, when I say that, when I ask you to show using the definition, what you have to do is you have to find the composite functions and show me that both ways is equal to x. So for instance, let's say I've got two equations. Like we know that one and this one are inverses of one another. We've already said that, right? Those two are inverses of one another. So I'm going to show you using the definition that they're inverses of one another. Is it number 5 that's that way? So if number 5 is like use the definition, then that's exactly, this is what I want to show you. This is what I want you to show me. What I want you to do is first show me that f, well that's a bad color. Try again. Use this black. Show me that f, that the composition of this, I need to show that it's equal to x. Okay, well remember, I'm going to erase this, and in its place, well, that is just equal to this. So in its place, I'm just going to write that cubed root of x. And now I'm going to take that cubed root of x and I'm going to put it into my f function. Take this and plug it into my f function. Take that and plug it in for x in there. So take this, plug it in for x in there. Instead of writing that x, I'm writing this. What is the cubed root of x cubed? What's that equal to? Well, that one's nice and easy. The cubed root of x is just equal to x. Hey, that's what we wanted to show, right? We wanted to show that it was equal to x. Now, it has to work both ways. It has to work this way, has to equal x. But then the other way has to equal x too. So in other words, I have to do it this way also. So I have to put my f function into my inverse and show that that is also equal. And if it also equals x, then I've proven it. I've shown it. I've used that definition. So I'm going to, instead of writing this f of x, I'm going to write x cubed. Then I'm going to put x cubed into that function. So in this function, in that function for x, I'm going to put in this x cubed. And what is the cubed root of x cubed? What is that equal to? Cubed root of x cubed is equal to? Got it last time, Austin. Let's see if you can do it again. What's it equal to? Yeah, it's equal to x. So we did it. We showed that this way it's equal to x and that way it's equal to x. So we used the definition to show that they're equal to x. Proof complete. You know, every time at the end of my haiku, or at the end of Jake's haiku, he puts a little symbol there. That little symbol in math means, hey, we're done. We've shown what we wanted to show. That's our proof complete symbol. QED, we're done. So tonight, when I ask you to use the definition, that's what I want you to do. This fancy definition, you've got to show the composition one way, show me that it equals x, then do that composition the other way to show me that it equals x. So in this homework, there's a lot of building upon stuff that we've already learned. Like, for instance, you're going to have to find inverses, but then you're going to get to use your parent functions to do some graphing of inverses. So it's just reminding you again how to use those transformations and how to graph parent functions. You're going to get to do compositions, so it will remind you of what we did last week. How do you do those compositions? And then we're just going to be doing some basic solving, so there'll be some of that in there too. So lots of review mixed in with that. Almost September, but not quite. Almost, but not quite. Okay, so how are we feeling so far? Looking kind of crazy? Okay, one last thing that I'm going to show you, which is going to take another hour. And that is, I'm going to show you how to find an inverse. So if I give you an equation, how do we find an inverse? I'll do it over here. By the way, those are the characteristics. Your x's and y's swap. Your graphs are symmetric about your y equals x, and your domain and range also swap. And then it is putting everything together in the last 2 weeks. We're putting it all together, all in one big lecture here. So you're getting to practice a little bit of everything. Your last thing is, another characteristic of it is that business of the composition this way is equal to that, to x, and the composition of this one is equal to x. So those are really the 4 characteristics of your inverse functions. And just know that all this means is that one machine undoes what the other machine did. So the 2 functions just undo what the other one did. Last time we made them all one machine, and now we're making it's still 2 machines, but they're undoing them. They're undo machine. Okay, now that we've got that, there are 4 steps to finding an inverse function. I'm going to show you the 4 steps for finding an inverse function. Here are the 4 steps for finding an inverse function. To find an inverse function. Step 1, we're going to replace f of x. Well, what is f of x? What is that f of x? Like right here, what is that equal to? This thing is equal to, what is that thing? I know it's equal to x cubed, but what else? What could I replace that with? That would mean the same thing. What else could I write right there? What does it mean? You guys know what it is. I'm going to replace this with, yeah, it's just y. You got it. Exactly. Good job. So that is just y. So we can replace it with y. Then that's going to be the first step, is we're just going to replace this with y. Then our second step is we're going to swap the x and y. And the reason we're going to swap that x and y is because you got it on the first part. You got it on the first one. That's right, Jessica. You go. Just replace that with y. And then our next step is to swap our x and y's, because when we're trying to find the inverse, we know the inverse is just our x's and our y's swap. So that's what we're going to do. Then, Jessica's a good friend. Okay, then what we're going to do is solve for y. And when we solve for y, good, smart, use those mamas. Solve for y, and that's going to give us our inverse function. When we solve for that y value, we've now found our inverse function. Then our last step is just going to be to replace that y that we've just found with this inverse function notation. Thanks, Jessica. I want to teach the world. I want to stay out of the kitchen, though. No more in the kitchen. Just teach math. Maybe reading. I like to teach reading, too. That's fun, also. It's a little 5-year-olds. They're a lot more fun than you guys are. I mean, adults are fun and all. Okay, so let's do an example where we just find the inverse. Let's start with an easy one. Let's start with an easy one. Now, I bet you can already tell me what the inverse is, because here, this is just multiplying. So I bet you can tell me what the inverse is. If that's multiplication, then what would the inverse be? I bet you can already tell me. The inverse of multiplying is? Yeah, is division. Good. So all I'm going to do here is end up, we'll see in the end if that makes sense. So first thing I'm going to do is replace this with y. So that's first step one. I'm just going to not, instead of writing that, I know it's equal to y, I'm just going to make it y. Thanks, Jessica. Math is just funny, so that makes it easy to make fun of it. Okay, so now I'm going to take my x's and y's and just swap them. Plop those two. So here's that function. My inverse function, these guys switch places. So that's all I'm going to do now. So this was step one. Step two, just swap those. Now step three is the hard part. On step three, I'm going to solve for y. Because once I get, this is the inverse function, my x's and y's flopped. But in this inverse function, I want to write it so that I have y equal to something. So I'm just going to get this y by himself. So what do I do to get y by himself? Well, I just divide by 3. To get y by himself. So you see where the early bird comes into play, where we're solving for y. So in step 3, I'm just solving. So I end up with x over 3 equals, well, that becomes 1. And I'm left with that y. Y'all got this? Now, I just found my inverse. This is the inverse of that. I swapped those and solved for y, and this is the inverse. So to tell the world I found the inverse, I'm just going to rewrite this y with that inverse notation. So instead of writing this y, I'm going to say, look, I did it. This is the inverse of that. And this inverse is this. Now I can check myself to make sure that they really are inverses by seeing if it undoes, if it really does work. So pick a number to plug in for x. What's your favorite number? Pick your favorite number to plug in for x. What do you like? What's your favorite number? What goes in there? See how long the delay is. There's always this nice delay, and when I ask a question and then y'all answer it, always lets me know just how long that delay, how long does it take for me to ask the question. Oh, 4, I like 4. So I'm going to take that 4 and plug it in there. So 3 times 4 gives me 12. Now, if this really is the inverse, when I put 12 in, I should get out 4. These two things should swap. So I'm going to put 12 in, and out should pop 4. Let's check it. 12 divided by 3, sure enough, is equal to 4. Check that out. I'm going to remember all the favorite numbers, though, for next time. So I got 6 and 5 and 13. I'm going to use those later. Of course I did. September was first, and then also September is my favorite. So, y'all have figured that out? Oh, well. She gets on with me and does her homework with me. Austin, if you would just join us, you too could get your homework done. It could happen. Okay, so notice my x and my y just flopped places in that inverse. That's what an inverse function does. It just flops it. And if we wanted to use this definition to show, so we can use the definition to show that their inverse is 2, what I would do is take them and show with the composition. So I'm going to do that again, because this is always the trickiest things for my students, is when I say use the definition, this is the part that y'all have trouble with the most. Well, this one and that early bird problem I did. So here, remember, all we're doing is we're going to use this definition. We're just going to find that composite. So again, instead of writing this, I'm going to write x over 3, or maybe we do that in a different color so we can see it. X over 3. I'm going to take that now and put it into this f function. So instead of writing the x, I write that function inside. That's that composite that we did last week. No, why don't you want to join us, Austin? You can have so much fun. And we would have more fun with your presence. It would be so much fun. Then this 3 and that 3 become 1, and look, I'm just left with x. I'm going to do it the other way now. Instead of this f of x, I'm going to write that 3x. Oops, lost my negative, my inverse function notation. Take this and plug it into that function. So this has got to go in place of that x. So instead of writing that x, I'm going to write the 3x in there. This goes there. Leaves me with x. Hey, look, we did it. We showed that this way it equals x and that way it equals x. So true enough, they're inverses of one another. Proof complete. Yay! So when I ask you to use the definition, that's all I mean for you to do, is use that composite function that you did last week and show me that they're both equal to x. You would think that is curious. That is curious. Why is September's favorite number not 9? That's a really good question. You would think it would be 9. Oh, that's hilarious. I think it should be also. Okay, so let's do a couple more where we find the inverse. Now that we've kind of got the idea of what an inverse is, we're getting the feel for it. Now we're going to just go through these steps to find the inverse. But I bet you can kind of intuitively begin to see what the inverse should include. You know, here I'm subtracting 1, so I'm thinking to myself, in my inverse, if here it's subtracting 1, that probably in somewhere I should probably have a plus something in there. And just intuitively, if this is cubing it, then I'm thinking to myself, somewhere in my inverse there's going to be a cubed root in there. It's kind of I'm kind of thinking those things to myself. But let's see if that actually happens, because sometimes I think that and then I get to the end and it doesn't work out that way. But let's see if it does. Okay, so first thing I'm going to do is replace that with y. So here I just replace with y. This is the same thing as that, right? I didn't change it. I just acknowledge that I can write f of x as y. These two things are the same thing. So that was step one. Step two, I'm just going to take, and now I'm going to create that inverse function by swapping my x's and my y's. That's it. Swap your x's and y's. Are we already friends, September? We should be friends on I'm already stalking her on Snapchat. I don't actually need to stalk her on Instagram also. I get to watch her on Snapchat. That's what I do, is stalk my students on Snapchat. And then, now I'm just going to solve for y. Now that I've found that inverse function, but I want it in this form where it's y equal to something. So if you followed, then we probably followed back, because that's what we do, we follow back. Okay, so now I'm going to solve. In order to solve, first thing I'm going to do is get y by itself. So I got to get rid of that guy, send him off to play blocks. So I'm going to add 1 to both sides. That's right, Thomas, I'm stalking you too. It's a true statement. Anytime you're posting anything on Snapchat, I'm paying attention. Y'all are pretty boring though. No concerts, that's good. Don't go to any. I like concerts though, because then I get to participate, virtually. I never have to go to one. But right now, don't do it. Nothing. Your boring lives are all I want to see right now. That's it. That's enough. That's enough. Okay, now I need the cubed, I got to get rid of that cube. So what I'm going to do is take the cubed root of this side. So I'm going to take the cubed root of both sides to get y by itself. Then we learned earlier, the cubed root, or we saw earlier, the cubed root of something being cubed is just equal to that number. But this side, I can't take the cubed root of it. I just have to stay there. That's right, Austin. If you do, I'll at least know about it. I mean, not that I'm going to do anything about it, but yeah, I would at least know. That's okay, though. I'm not judgy. I'm just like, oh, look, fun times. Okay, now I'm going to replace that y and let the world know that this is the inverse of that. And to show that these are the inverses, I just write that notation to let them know it's the inverse. But I found the inverse here. And look, we thought it was going to have a +1. Sure enough, it had a +1. We thought it was going to have a cubed root. Sure enough, it has a cubed root. There you go. We found the inverse. Now we can test it by putting in here, let me ask you this. Here's a question for you. After I erase. What if I wanted to know what is the what is this? This inverse function of 7. How could we find out what this is equal to? What would we do to find out what this is equal to? Yeah, if I were to do the composition of one another, they turn out to be x. They turn out to be compositions. But this 7, aren't I putting it in place of that x? So don't I just take this 7 and put it in place here? To say, well, okay, what is f of 7. Put it in there, 7 plus 1, which is the cubed root of 8, which is equal to 2. Or, you're right, September, what we could do is this one's x, but isn't it that one's y? You're exactly right. I could, instead of writing this, I could write in here for y, this was this one's x, I could put it in there for y and solve. That's exactly right. I could do it that way. I could take this, because this one's x is that one's y. I could take it and plug it in there. Now let's just see if we get out this 2. You're exactly right. This one's x and that one's y should swap places. So notice this one's y in my f function. So add 1 to both sides and you get 8 equals x cubed. Take the cubed root of both sides, and sure enough, x is just equal to 2. The x is in the y swap. You're exactly right. So this one, if I'm putting it in here as x, it's that one's y. And whatever I spit out, this one's y becomes that one's x. So just a little bit tonight, if I ask you for this, you could just substitute that in for y, because the x of this guy is the y of that one. How's that for confusing? It totally makes sense, right? Maybe so, maybe not. If not, just find the inverse function and then stick it in. Either way, it works out. Okay, let's practice finding a few more inverses. Did it kind of make sense anyway? I don't know if it did or not. Let's try this one. Four over x plus 5, and I need to not forget, I'm going to write myself a note to talk about the horizontal line test. I'll talk about that here in just a second. Yeah, it is so exciting. I love it. It is. It's exciting. Okay, so here I have a function, and I just want to find its inverse. So I bet you guys can do this now. Y'all are getting really good at it. I bet you can do it. I wish you were in class so I could be like, do it for me, show me, tell me. But no, just lag. Okay, so I'm going to replace that with y. That's step 1. They are racking up. They are racking up. Now your next job is to get Jacob in class. If you could get Jacob in class where he's here too, talk about the points racking up. That's our next step. Anybody have his number that you can text him and tell him to get in class? I think he's the only one missing. I think everybody else is here. Is there anybody else missing? I haven't seen Fernando tonight. Is Fernando here tonight? He's been in all the other ones, but is Fernando here tonight? I haven't seen Cherish here tonight either. Is Cherish here tonight? There's a couple of people no shows here. Y'all get them here. We can do it. They can get here. We can do it. Okay, that was step 1. I'm just replacing that with that. Step 2, flop these two guys. Just flop them. And that creates, because my x's and my y's just switch places in my inverse, my inputs and my outputs swap. I found the inverse. It's just I need it in that format where it's y equals blah. Okay, good. Cherish is here. Okay, good. Oh, this one might be a little more challenging to solve for than the other ones. But I know you can do it. So first, ignore the y that's attached to its parent and get rid of that guy who's okay. So send him off to play blocks. Subtract 5 from both sides. And I have x minus 5. All right, yay! That's what we mean? Oh, Sierra too. You know what? I haven't seen Sierra since she left for Florida. Has anybody heard from her? She went off to Florida and never came back. Okay, good. You're getting here, and that really is bonus points. Yes. Get him to start showing up. It's a big deal. Okay, now I've got y almost by itself, but not quite. It's in the denominator. How am I going to get this y out of the denominator? That's a weird place for it to be. But we know when it's in the denominator, what do we do to get rid of the denominator? How do we get it out of the denominator? What do we do? I don't know. She's probably having fun in Florida. Got stuck there or something. But she could do it online through us if we could just get a hold of her to tell her. Yeah. It's not too late either. I like it. Multiply. If I multiply by 4, though, think about multiplying by 4. I just multiply straight across, and I end up with 16 over y. Because remember, when I multiply fractions, I just multiply straight across. So I like the idea of multiplying, but what are we going to multiply by to get rid of that y, to get it off of the bottom? How about instead of multiplying by this y, the 4, I multiply by the y? Because normally we multiply by that denominator, right? To help us get rid of it. So I'm going to multiply both sides by my y. Yeah, you got it. Good job. That's exactly it. So I've got y times this. And here, the denominator, that becomes 1. Now when I multiply, that's on top, that's on bottom, it becomes 1. It leaves me that 4. Now remember earlier, I factored out the y to get him out of the mess he was in? If I distribute here, I'm just going to get the y mixed back up with those characters again. I don't want my y in there with those other guys. He's already almost by himself. So instead of multiplying here, he's already out there. Instead, let's get rid of those, unsavory type. So we can divide here by those unsavories to get the y by himself. He needs to be isolating. Look at him. He's not physically distancing. He's going to get us all killed. None of that. Go. Divide those people off, send them home. Now, y is safely by himself. That's right. Normally you would distribute it. That's kind of the idea. But yeah, factoring back out. Don't get him mixed up with those other people. Physical distancing. Then I'm just going to, last step, I got to tell my reader that this is the inverse of that. And so to tell my reader that, I just swap and put this notation to let my reader know this is the inverse of that. And this kind of makes sense, right? Here I was adding 5, there I'm subtracting 5. Well, here I'm still got it is a little bit, I want it to be multiplication, and instead it's division. Oh well. We got 1 out of the 2. We could check ourselves since we're like, well, that's a little weird. Am I sure that they're inverses? I can check myself by putting in your favorite number is 6. I think that was Austin's favorite number, right? So if I put in that 6 into my first one, well, I get out, I need a common denominator for 4, 6 plus, well, to make that into 6, I have to multiply the bottom by 6, so then I have to multiply the top by 6, by 6 over 6. So then I get 30 over 6, which is 34 6, or that's 17 thirds. Man, that wasn't a nice pretty one, but yeah. Okay, now I'm going to take that 17 thirds in here, and I should get out 6. If they really are inverses, when I put in that 17/3, I should get out 6. Let's see if we really do. So I'm going to take and put in 17/3, and I should get out, yuck. We can do it though. We're good at this algebra now. We got this. Find a common denominator. So 3 is going to be my common denominator. Rewrite this. 17/3 minus, what goes on top? Oh yeah, 15/3. So 17/3 minus 15/3 is just 15, 16, 17, 2/3. Oh, it does look beautiful. I think it's so gorgeous. And we know how to divide with fractions. We just say, hey, it's this divided by that. We keep, change, flip. Man, KFC sounds really good right now. To be able to go get some nasty, gross food that I need to live off of. I should be losing weight, but no, not happening. Okay, keep, change, flip. 2 goes into 4, 2 times 3 is 6. Look at that, we got out the 6. So sure enough, we put in that y, and we got out the 6. So they just swap places. So yes, they are inverses of one another. Oh man, they know, Amanda. They know how desperate we are. I know. They know we're desperate for some fast food. I don't understand why eating chicken and bell peppers and onions is not helping me lose weight. I don't understand. Are you really? Did he teach you how to make good fried chicken? Fried chicken. All right, let's do one more. Let me make sure one more, and then I've got to tell you about the horizontal line test before we leave. So one more. Hardest one you're going to have tonight. I think we already did the hardest one, but here's another one. Hardest one you're going to have in the homework. It does sound good. My dad actually makes the best fried chicken. If you want good fried chicken, you get my dad to make it. That's pretty cool. That's pretty cool. Related to the Colonel. That's a cool person to be related to. It is just like our early bird. It's going to be really similar to our early bird. Ribs does sound good too. Y'all are making me hungry. I like it. Multiply both sides. Well, first, swap it out with y. And then swap the places. So here's my inverse. So this was step 1. This is step 2. And now you're right. Multiply both sides by that y plus 1. Now in this case, it's not y. So the x is going to get mixed up with him. So in step 3, I've got to distribute it so that then I can separate them. So here I'm going to distribute it to get xy plus x equals, these guys become 1, and I'm left with 2y minus 3. Now what? This is the hard step. This is the hardest step, is remembering what to do there. What now? Because this is the tricky part. These next 2 steps are the hardest part. Do you remember? Add 3, I like it. Get that 3 away from that y. Tell them, go get in your own house and stay there. You're not part of the y family. Oh, he doesn't have anybody to add to, so he's just... Now what? Oh yeah, he needs to go get in his house with the Y family. So now I have my Y family all together, but Y needs to physically distance. Y needs to physically distance, so how do I physically distance him? How do I get him out of there? I can't just subtract him off because he's part of this right now. Remember how to physically distance him? It's my favorite thing. How are they going to physically distance? He's going to tell them, F that. F you. And by Fing that, it's going to factor him out. There, now he's not part of those. He pulls it out, that's exactly right. Tell him, F you, go away. Factor him out. Now we can divide both sides by this. And Y will physically be separated from those other ones. Which is our whole goal, is to physically distance. By the way, the physical distancing is working. We're doing it. Now keep it up. Oh, and then last step, just tell everybody, look, I did it. I found the inverse. This is the inverse of that. Those two are inverses of one another. Man, it's really hard to see the inverse there. You know, I guess you can kind of see it. Here I see a division. Instead of a multiplication, it's dividing by that 2. I kind of see it because this is adding a 3 instead of, but it's a stretch there to see it in there. One last show. If I wanted to prove that these two were inverses, I could find their composition, and they better come out to be x. So if I did this, f of that, man, that one's going to be hard. So I'm going to write, instead of this, I'm going to write this crazy thing. That's right, they are increasing a lot, but we are, because we're self-distancing, because we're distancing away from one another, physically distancing, our numbers are lower than they would have been. And it keeps pushing back the peak here in Temple in Bell County. I'll post in our discussion the most recent graph of the peak and what our physical distancing does for us. I did that in my stats class because it really relates to stats. But I'll show you all also. And I think your application task this weekend, because on Thursday we're going to learn about exponential functions, your task this weekend is to watch a video, and it's about the COVID and how we're exponentially growing, and a little bit about that. So hopefully it won't scare you too bad. It'll show you just the reason that we need a physical distance. It is helping. They are skyrocketing, but at the same time, it is helping. It is helping. Okay, I'm going to take this and put it into my f function. I know this is crazy. So I'm going to put this in everywhere I see an x. So I'm not going to write that x. I'm not going to write this x. So I'm just using the definition to show that they really are inverses. And you're right, September, this is gross. So x plus 3 over 2 minus x, and I'm putting it in here too. So just replacing those x's with that. Now I'm going to multiply. So distribute that. And you got 2x plus 6 over 2 minus x. Yuck. Save Halloween. Self-quarantine. I like it. It's a new chant. Save Halloween. Self-quarantine. Save Halloween. Self-quarantine. Maybe by Halloween we'll be good. There you go. Save your birthday. Maybe by then. I don't know. It really depends on if we get a vaccine by then. Okay, then I need a common denominator. So if I put 2 minus x on the bottom of here, then I have to do 2 minus x on the top there. Same thing down here. There's nothing to, I don't have to multiply or anything on this one. But I do need that common denominator. So 2 minus x and 2 minus x. I think y'all got to play with some things like this in the last lesson, didn't you? Did some compositions that looked that nasty? Yes. X's you should always get rid of. You F them too. Fact them right out of there. And then the number one thing is you don't get in relationships. Stay out of them completely. Number one rule in life, stay out of relationships. But if you do get in one, oh my gosh, number 2 rule, don't have children. Just don't do it. Don't do it. Don't do it. No children. No children. It's like my number, that's the biggest thing. Don't have kids. Right, Amanda? Don't do it. Okay, now I'm going to combine these. Denominator, 2x plus 6. Multiply that. So you got negative 6 plus x. Craziness. No children. Don't do it. I know, there are a few of us that did it. We had kids and that should be the number one thing you tell people is don't have kids. Don't have kids. They do. They ruin everything. For those of us who are stuck with them already, I mean, I guess we put up with them. All right, notice all I did was distribute this, and then I'm adding my numerators, keeping my denominator. Here I'm just adding those numerators, keeping my denominator. These guys become 0. That x and that x become 0. I ran out of room. So I have now on top 2x plus x over 2 minus x. And on bottom, did I do something wrong? I have 5 over 2 minus x. Maybe? I'm not liking where this is going. Somewhere I need it to be an x somewhere. Maybe it'll work out. We'll keep going. In the meantime, Amanda, look and see if I messed up somewhere. Where did I leave off? Okay, so now I'm going to take this and divide by that. So this divided by that, I just keep, change, flip. So I'm going to flip him, change my sign. That 5, where'd that 5 come from? Something's not quite right. That goes away and that goes away. That really needs to be a 2. No, that needs to be a 3. I don't know what that needs to be, but it doesn't need to be a 5. Okay, here, I'm going to factor out an x out of there, and I've got 2 plus 1. 2x is plus I can do this. 2x's plus x gives me 3x times this 5 is going to be on bottom. It needs to be a 3. Where did I go wrong? Do y'all see it? I didn't subtract it. Oh, look. This negative 3 times 2 gives me a negative 6. But this negative 3 times a negative x should have been a positive 3x. Oh, so that means this should have been a, no, not that one. This one should have been a 3x, which means when I add those, I get a 5x. Oh, thank goodness. It's because y'all aren't in class to correct me right then. This lag business, y'all saw it, and y'all were just like, well, we'll let her go. Yeah, thank goodness. Then these 5s go boop, and look, sure enough, it's an x. Yay! Now we would have to do it the other way too to make sure. But if we get an x both ways, then we go, yes, they are inverses. So there for a minute I was thinking maybe we got the inverse wrong. But no, we just did our math wrong here. Okay, so you see how you can use the definition to make sure they're inverses. You can also just plug in a number and then use that and make sure it undoes it. And there are just 4 steps to finding the inverse. Substitute your y, swap your x's and y's, solve, and then tell your reader you've done it. Okay, let me explain this horizontal line test. So you remember in the fancy definition, it said for all x in the domain. It had that fancy math talk and said for all x in the domain. So what that tells us, that little part, is talking about the fact that in order for us to be able to find an inverse, the function has to pass the horizontal line test. It has to be 1 to 1. Has to pass the horizontal line test. So you remember, in order for a function to be a function, it has to pass the vertical line test. But in order for us to be able to find its inverse, it has to pass the horizontal line test. So like, for instance, a linear function. All of our x values have exactly one y value. It passes the vertical line test. But now all of my y values have exactly one x. They have exactly one input. So it passes the horizontal line test. So we can find inverse functions of linear functions. In fact, we did that when we did that 3x. We found the inverse of a linear function. Let's look at another one. How about our cubic function? It's a function because it passes the vertical line test. We can find its inverse because it passes the horizontal line test. Everywhere I draw a horizontal line, I'm only going to hit it once. We can find its inverse. In fact, we did that. We found the inverse of x cubed. What about this one? If I draw a vertical line, it only hits one time, so it is a function. Well, look, when I draw a horizontal line, it hits twice. This y value has 2 x values. That y value is with her in the morning and him in the afternoon. That's not cool. Don't be cheating. Don't do it. So this one we can't find the inverse of. It doesn't pass the horizontal line test. Now we can find the inverse if we will restrict its domain. In other words, if we'll take this quadratic and just look at it for part of it. So kind of like your piecewise function was this last week, where I said it just, from where x is less than 2 or whatever. so I'm looking at just a piece of it, I can find the inverse of it if I restrict its domain. It says 1 to 1. The function is 1 to 1, which means that it passes the horizontal line test. That's all it means. So like my absolute value one does not pass the horizontal line test. Right here, there, and there. Not cool. So I can't find the inverse of that. Now if I restrict the domain and I only look at a piece of it, then I can find the inverse of that. So in order for me to be able to find the inverse, it has to be 1 to 1. In other words, my x's have to all have 1 y, and all my y's have to have 1 x. That's right. Got a bunch of cheaters in this class. I don't know what the deal is, but x's and y's all cheat. And got all this issue with math and relationships, and the best idea is just to stay out of relationships altogether. Then you don't have to worry about it. Yeah, if they fail the horizontal line test, then there's no inverse. We can't find the inverse. No inverse. Okay, so now I'm going to jump on Discord. Y'all are going to jump on Discord with me, and you're going to do your homework so that you can turn in and you can get points, and then you can pass this class and be done with it. That's the plan. And then you can take me for stats this summer and have some fun this summer. Yeah. All right, so I'll see you online. Come join me. It's going to be great. Right now, come do it. If not, I'll be online all day tomorrow, except for when I'm streaming from 9:30 to 10:30 for statistics. That's it. Supermoon, you can do that afterwards. We'll check that out after you're done with the homework. The sun's not up down yet. So we'll check that out after you've done it. You'll be done by then. Come jump on. We'll get it done. Come on. You can do it. You can do it. You can do it. All right. I'll see y'all. Hey, math made simple. It's Simpson Math. Thanks for watching.